We are in chapter 1. We are going to start talking in this chapter about a lot of things that you've seen before. Linear functions, so like everything to do with lines, inequalities, solving equations, those kinds of things. Today we are going to look at 3 formulas, distance, midpoint, and Pythagorean theorem, and just make sure we know how to use all of those. So you've seen them all before. There is nothing I'm teaching you today that you have not done in Algebra 2. So it's just a really short review day. First thing I'm going to put up here are the 3 formulas. So if you would just write those down in your notes, and then I'll talk about it after you get it all written down. I'll scroll down in a minute to get the last one. The distance and the midpoint formulas both apply when you have 2 ordered pairs. That's what the x1, x2, it's the x from the first ordered pair and the x from the second ordered pair. Same thing with the y's. We know every ordered pair has an x and a y value. You guys remember that part? The Pythagorean theorem, where do you use this? What shape does it apply to? Okay, there's 3 variables. So it has 3. A triangle, yes. More specifically, it has to be a right triangle for the Pythagorean theorem to work. A and B are the legs of the triangle, the 2 sides touching the right angle. C is the hypotenuse, the longest side across from the right angle. So Pythagorean theorem only applies in that scenario of the right triangle. All right, let's just work through some problems. So I want to find the distance between the points 3, -4, and 5, +4. And you guys just got done writing down the distance formula. All right. In these ordered pairs, it doesn't matter which x you use first, but the mistake I see, if I call this x1, that's the x of the first ordered pair, what's this -4? That's y1. So this is like your x2 and your y2. So we do the square root of x2, so 5, minus 3 squared, plus y2 is 4, minus y1 is -4 squared. Okay, so then if we work through this, 5 minus 3, 2 squared, 4 minus -4 is 4 plus 4, so 8 squared. I do not want decimals on any answers. I want your answer in lowest radical form. That means if 68 can be broken down, if it's divisible by a perfect square, I expect you to do that. How could you figure this out if it can be broken down? What do you do? Yeah. Grab your calculator. Think about your perfect squares. 4. So can you do, if you do 68 divided by 4, you get
22.
close. So we can break it into a 4 and a 17. Square root of 4 is 2, so my answer is 2 radical 17. Are you guys okay with the distance formula? Do we need more examples of plugging that into the formula? Once you plug it in, it's just a matter of order of operations and then breaking down the radicals like we were doing on our last test. Let's look at this. A right triangle. I'm going to draw myself a picture. Has a hypotenuse of 13. Where's the hypotenuse in a right triangle? And one leg of length 12. So it doesn't matter which one, just pick one of them. What's the length of the remaining leg? So in your right triangle, you have sides A, B, and C. C is the hypotenuse. I'm just going to call that A for a moment. So we can do A squared plus B squared equals C squared. So my B is 12. And C is 13. Twelve squared is 144. 13 squared is 169. Subtract over your 144. And we'll get a 25. Then the opposite of a square is a square root. Anytime you add a square root, you're supposed to add a plus and a minus with it. Would I need that here? Can you draw me a triangle that has a side length of -5? No. So even though we're adding a square root, since we're talking about a length, it can't be negative, so I only have to do the positive, and I get 5. Again, if it's not a perfect square, if it were like the square root of 50, you just break down your radical as far as you can. Questions there? So this time I want the midpoint. The midpoint is just an ordered pair. So on your formula you wrote it down. It's like finding the average. So you find your average x, so you add your x's together, I think, and divide by 2. Find your average y, so add those together and divide by 2. So this -5 is like my x1, positive 5 would be y1, 3 is my x2, and 1 would be my y2. If I plug that in, x1 is -5, plus x2 is 3 over 2. y1 is positive 5 plus y2 is 1 divided by 2. Negative 5 plus 3 is negative 2 divided by positive 2 would be negative 1. 5 plus 1 is 6 divided by 2 is 3. So we get an ordered pair for the final answer. Questions on that one? I'm going to ask something else about midpoint, but I'm changing the question a little bit. I want to find the other endpoint. So instead of giving you 2 endpoints and asking you to find the middle, I gave you the middle and one of the endpoints. And we're finding the other one. All right. There are 2 ways to do this. There's the algebra way, so using our formula, and then there's kind of a reasoning way, where we can just think about it. So I'd like to show you the 2 different options and see what you guys think. The first way, if we do the midpoint formula, I don't know my other endpoint, so I could just call it xy for a second. The midpoint formula says to find the x value of the ordered pair, you add your x's up and divide by 2. So I could do the x's from my 2 endpoints, so 8 plus x divided by 2, and that should equal the x value of the midpoint, which was 4. Can you solve that equation for x? Times 2. Subtract your 8, and x is 0. Then we do the same thing for the y's. So to find the y value of the midpoint, the formula says you add up the 2 y's from your endpoints, so negative 20 plus y, divide by 2, and what would that one equal? Negative 4, the y value of the middle. So we multiply our 2, add your 20, and we'll get 12. So the other endpoint is 0, 12. So you just use xy for the second endpoint and plug into your midpoint formula. The other option. Can I erase this for a second? Show you another way. Isn't really using the formula so much as just thinking through the problem. So if I just drew myself a picture. Okay, this first endpoint, I'm not plotting these correctly at all, I'm just marking them. This was the end, the middle was 4, negative 4. I have to find the other end. So what we do is we look for a pattern. Okay, if you are at positive 8, what do you have to add or subtract to get down to positive 4? So we add negative 4 or subtract 4. So then you just do it again. So negative 4 plus 4, or think 4 minus 4, and you get 0. So we do the same thing with our y's. If we start at negative 20, What do you have to add or subtract to get a negative 4? Add 16. So if we add 16 again, that's just like negative 4 plus 16, and we get 12. Is that the same answer we found from the formula? Yeah. So it's really just how you prefer to think about it. How many of you like the first way with formulas? Okay. What about the second way? Okay. So we're always split. Some people prefer the algebra, some people like to reason through it. Why don't you guys try B? Whichever way you prefer. Go ahead and find that second endpoint. So if you did it the algebra way, you use xy for the second endpoint. Add your x's up, divide by 2, and it has to equal the x value of the midpoint, which was 8. And it'll be 12 plus y divided by 2 equals negative 2. Okay. And so you get an x and a y that way. The second option, we kind of reason through it. We're starting at negative 6, 12. The middle is 8, negative 2. How do we get to the end? So to get from negative 6 to 8, what do? So then if you add 14 again, 8 plus 14 gives you 22. If you're at your y's, to get from 12 to negative 2, you subtract 14. So if we do negative 2 minus 14, you get negative 16. So same answer, two different approaches. Are there any questions at all? Okay, so that is actually the end of section 1. Your assignment is on Math Excel. It is a very short assignment. It's like 6 questions today. So I'm going to give you some time to work on that. I'll let you guys decide. Tomorrow I'm covering section 2, and there'll be another Math Excel assignment. Do you want me to take 5 or 10 minutes and start that section today? So tomorrow's lesson's pretty short too. You guys are the ones that will be watching it on a video tomorrow. So what would you prefer? Do you want me to start it or not? Can I just do like the new piece? How about that? Because most of it's talking about functions, so it's mostly review stuff, but there is one new piece we're going to be using a different notation. So can I just talk about that part today? And then I'll finish up that section tomorrow. So I promise I'm still going to give you guys time to work on the homework. I'm not going to talk for very long. Okay, so section 2, we're talking about relations and functions. What's going to change in this section is how we write inequalities. We are going to start using something called interval notation today or tomorrow. Okay, so before, if you solved a problem and you got an answer like x is greater than negative 2, That's inequality notation, set builder notation. What that means is you are starting at -2 and you had anything larger than that. Interval notation, it kind of looks sometimes like an ordered pair. It gives a starting and a stopping point. So if I'm going to write this as an interval, you go left to right, small to large. So the first number, it starts at -2. And then it keeps going forever. So if something never ends, we call that infinity. It's like a sideways 8. Then interval notation, we also have the option of parentheses or brackets. If something is not equal to, it gets a parenthesis. So this was not equal to -2, so my -2 has a parenthesis. Infinity is not an actual number, so can you equal infinity? No, so infinity would also get a parenthesis. If it's an equal to, like if I said x is greater than or equal to -2, that would fill in this circle. So we're still starting at -2, but this time you can equal to -2, so the -2 gets a square bracket. You still can't equal infinity, so infinity still has a parenthesis with it. Okay, so parentheses are not equal to, brackets mean equal to. So I just want to take a few inequalities and see if we can write them as an interval and show that we understand that notation. It can be helpful, especially when you're first learning this, if you just draw yourself a number line. You don't have to, that's not part of the answer, but it can make it a little more clear. So if I took 1 is less than or equal to x is less than or equal to 3. If I'm just drawing myself a really rough number line. This starts at 1. It had an equal to. You guys have used closed circles for that when you graphed them in the past. Usually in this class we kind of switch and use parentheses and brackets just so our number line matches the notation we use later on. So equal to is a bracket. Stops at 3, it has another equal to, so that's a bracket. So my interval notation begins at 1, it can equal to 1, so it gets a bracket, comma, stops at 3, can equal to 3, so the 3 gets a bracket. Always go left to right, small to large. So what would this look like? -4 is less than x is less than 0. Parenthesis, because there's no equal to, would start at -4, comma, end at 0. That didn't have an equal to either, so they're both parentheses. Okay, x is greater than 5. So it'd be starting at 5, and you want everything larger than that, so what would that notation be? 5, comma, infinity. You're not equal to infinity, so it gets a parenthesis, always. And last one. X is less than or equal to 1. So that's everything smaller than 1. As we're going from left to right, this is going forever in the negative direction. We call that negative infinity. You can't equal it, so it gets parentheses. Comma, we stop at 1, and the 1 had an equal to, so it gets a bracket. So negative infinity, comma 1. That's where I'm stopping today. Tomorrow I'll pick up with that section, and there will be a math Excel assignment. So the one that's open today should be posted already. Section 1.1. I have it set to be due by 3 o'clock tomorrow. Usually on the math Excel I make them do at 3 o'clock the day that it's due. That way if you have questions, you've got some time to email me. Remember, you can use that Ask My Instructor if you're working on it at home, and it'll shoot me an email and let me know what you're looking at.